Hey Maddie, so Teresa here. I'm going to be talking today about what is the equivalent of section 1.3 in the textbook that you can find online. But there's a lot of jargon in here, so I'm going to try to simplify some of the ideas and maybe take you through a couple of examples. So for now, what I'm going to do is I'm just going to put this aside and get going. So I want to start by talking about some ideas that should be familiar to you, and then I'm going to extend that to what we're going to be doing today. So from grade 10 and 11, you would have learned, you can take the graph of, let's say, y equals a times x minus, I'm just giving you these random values, 2 and x plus 1, for example. And I can utilize this factored form of a quadratic in order to graph it, right? In order to create a decent sketch. So, for instance, this a value here tells me the stretch. It also tells me whether this has been reflected or not in the x-axis, right? Whether it's opening upward or downward. But I can also tell by equating each of these to 0, each of these little factors to 0. So for instance, if I set x minus 2 to 0 and x plus 1 to 0, then I know that I have the roots or the x-intercepts of this function. So for instance, I know I have a root at x equals 2, and I know I have a root at x equals negative 1. So if I wanted to go ahead and create a decent, half-decent sketch of this, if I took the value of a, let's say a was a positive value, I know that this would be a parabola opening upward with one root at, let's say, positive 2 for argument's sake, somewhere over here at 2, and then another one at negative 1, right? And then that would allow me to, sketch this graph. And if I wanted even more information, I could get, a point like the vertex by looking at the midpoint between those two roots. So the same thing holds true if we're talking about our larger order polynomials, so i.e. cubic and quartic, quintic, and so on and so forth. So let me show you what I mean. So let's just say I added another factor to all of this. So I'm going to make it green. So let's say I added a third factor to this. Let's say x, I'm going to say plus 3. Right? And so we're going to also say that so now what I've done is I've created 3 x-intercepts instead of simply 2. So that third x-intercept is going to be at x equals negative 3 once I set that x plus 3 to 0. So now I know I have a third x-intercept over here at negative 3. There we go. So that will help us now to sketch this. So we're going to recall some of the ideas about odd and even functions here to help guide us. So since if I were to FOIL all of this out, I'd have an x times an x times an x at some point. So that means that this function is therefore going to be cubic. I can tell that just because of, if I were to use my exponent laws, 3 factors of x will give me an x cubed if I were to expand that thing. So I know this is a cubic. Now we're going to still assume that we have our stretch factor, our leading coefficient, as being positive. So if this is indeed x, some kind of cubic function, that means this is an odd function that is with a positive leading coefficient. So you'll remember last time we talked about how those would be more like a line. All of our odd functions are going to be more like a line, and since it is positive, it's going to be more like a line that is sloping upward. So in other words, my graph of my cubic function is going to start down here, and it's going to end over here. So we're going to kind of ignore this blue graph, and in my green graph, I'm going to attempt to sketch this. So I know I would be starting down here, and I'm going to have to go through this root. And then I'm going to have to go through this other route somehow and then go back upwards. And so I would guess that if I were to sketch this graph, it would look something like that. Now, There are some other pieces of the puzzle that I can also utilize. So I'm just going to take this and just squish it down a little bit. There we go. Which is that I can also find out if I know my stretch factor. So let's change this a little bit. I'm going to make this now y equals, I'm just going to make it the a value equal to +1 just to keep things simple. So now my graph becomes x minus 2, my function becomes rather x plus 1, and then let me make this a little smaller, x plus 3. Now another thing I can do is I can find out my y-intercept, right? I found out all the x-intercepts by looking at the factored form and setting each factor to 0. But if I want to find the y-intercept is found at the point where x is equal to 0. So that's my y-intercept. And that will just give me another coordinate to plot this effectively, but along my y-axis. Because I don't know, I've kind of just, assumed it goes up only so far, then back down, and then goes down again and then back up. But if I had an idea about where along here that y-intercept is, it would just give me, make my sketch just a little bit better. So the way that I would do that is I go ahead and I make my x value in this function 0, and I look for the value of y that results. So y equals, so all I'm doing is subbing in 0 for x here. And let's see what that yields me. So -2 times +1 times 3, so at y equals -6. And so that also makes sense given what my graph looks like so far, right? Like I would be concerned if the y-intercept that I got was up here, because that doesn't make sense given the green line that I've already sketched. So what that tells me is that I didn't dip low enough when I went to sketch. So let's just say that's -6 there. When I went to sketch my graph, I really needed to go kind of more like that and up. Okay, so let's explore a couple of different examples to help you out. So let's just summarize that before we go forward. Number 1, what would I do? I would make sure it's in factored form. So, and then in factored form, I would find the roots and plot them. Then what I would do is I would look to see, is my function odd or even? Because that's going to tell me whether it's like a line or bull. The third thing I'm going to do is look at the sign of my leading coefficient to see whether it is increasing from left to right or decreasing from left to right, if it's odd, or if it's even, whether it's opening upward or downward in its sort of bowl-like shape. Okay? But the fourth thing that I would do is I would find the y-intercept, and that just gives me another nice point to kind of work with. So the roots, in other words, these are the x-intercepts. So if I have those pieces of the puzzle, that should help me pretty dramatically in my quest to sketch these functions. So here is where I'm going to remind you of another idea that should have come up in your grade 10 and probably, definitely in your grade 11 course, which is what happens if you have two identical roots. So in the case of a quadratic, I'm just making this up. Let's say my quadratic function was y equals x, let's say -3 all squared, right? So what I have here is a double root or two identical roots. And I know that because really expanded, what this looks like is this, x minus 3 times x minus 3, which means I have two of the same roots, both at x equals +3, right? So there are my two roots. They're both at x equals 3. So how does that translate if I try to sketch this? Well, if I were to try to sketch this, let's see what I would get. Well, first of all, let me plot those at 3. If I have a double root, then that means that graph, that is exactly where my vertex is. So in other words, the curve will touch but not cross that graph. Now, Assuming our stretch factor is 1 here, it means our leading coefficient is positive. So what this would look like would be a graph, a parabola that opens upward like that touches but doesn't cross that, that x-axis. Hopefully that's familiar to you. So now what I'm going to do is I'm going to add another factor, just like we did last time. And I'm going to make it, let's say, x plus 2. So now, now what I have, my entire function is x plus 2, which means that, I know that I have another root at x equals negative 2. So, here we go. This is at positive 3. Over here I have, let's say, for argument's sake, about there, negative 2. So now I can see, based on the number of factors of x, I've got 1, 2, 3 factors of x. Again, this is a cubic. So being a cubic, I know it's also going to have that, it's going to look more like a line. And it's also, I've chosen to make this a positive coefficient, which means that it's going to start down here and go upward. But now I've got this situation here where I have my double root, right? So somehow I need to make this work. So another piece, so really I know that I'm going to cross here and then touch and then go back up again somehow, right? That I think is what's going to happen here. And I can tell, so in other words, I'm kind of bumbling with this, but if I have a single root, right? Or in other words, or an odd number of the same root, then that means the line is going to cross. If I have a double root or an even number of the same root, then it's going to just kiss or touch, but not cross. Okay, so now another piece of information, I'm going to make this a little bit smaller. So another piece of information that I will find useful is if I go ahead in this function that I have right here and I try to find the y-intercept. So remember, the y-intercept is where x equals 0. So my y is going to be equal to 0 minus 3 times 0 minus 3 times 0 plus 2. So, that's going to give me negative 3, positive 2. So 9, 18. Ooh, yee. So, my y-intercept is going to be way the heck up here somewhere. So that's helpful. And so again, let's apply all of the information that we know so far. So odd degree means it's starting down here. I've got a single root at negative 2, so it's going to cross. I know that my at positive 3, I have a double root, so it's going to kiss that curve. And I know it's going to go through this y-intercept up here. So putting all of those pieces together cleanly, I think it's going to look something like this. Boom, boom, and then up. Okay, so that is, that's the gist of it. That's, those are the big ideas around how to sketch higher order polynomials. I think it'll be helpful for you to see an example of how to do a quartic, just to remind you about even functions. So I'm going to do an example of that next. So I found a couple of quartic functions here for us to look at, and I think it's important for us, and I've pulled up our little kind of roadmap to how we want to go about sketching, and I'm going to add to this, we want to look at the order of the roots, and so the order of the roots really describes, is it a single root, is it a double root, are there an odd number of roots or not? So the order of the roots. Right, and so, so I'm going to write just to remind us, does it cross or does it kind of touch without crossing? There we go. So now, just to look at this, I can tell right off the bat that these are both quartic functions because I see 1, 2, 3, 4 factors of x, right? Which means it's going to yield 4 different roots. And the same one down here, right? I've got, x minus 2 squared, but then 2 more factors. So those are both quartic functions. So let's focus on I first. So I'm going to do that one first. Let's just sketch it out. And if you want, maybe what you can do is you can pause the video and try this if you're feeling like you're ready to do that. Okay, so now first my roots. My roots I can tell just simply by making setting each of these factors to 0. So x plus 1 is going to give me a root at -1. X minus 2 is going to give me a root at +2. And again, like I'm just really loosely sketching this. I don't even have graph paper. I would guess that you would be expected to use graph paper. Just a hunch. And so if I go about equal distance here, this would be a 4, another root at 4. And then it looks like I have another root at 1, 2, 3, roughly here, -3. Okay, so there I've kind of guessed out where my roots are going to be. So now I also want to look to see, well, is this an odd or an even function, right? So I know that this is a quartic function. So quartic, in other words, is, x to the power of 4. So that is most definitely even, which means it's going to look more like a bowl than it is a lime. But next step number 3 here, I want to look at my leading coefficient, and my leading coefficient is negative, which means it's a bowl that's kind of opening downward, or like it's going to look like a hill. So it's going to be downward. And so the last thing I can do if I want to is find that y-intercept to help me as a fifth coordinate here. So here we are here. So if I substitute in 0 for each of my x values here, I'm going to end up with 1 times -2, which gives me -2 times -4, which gives me +8. And then +8 times 3 is going to give me +24. So it looks like I have a y-intercept at +24. Nope, let me remind you, I forgot about this negative out here, so it's going to be at -24. So I'm going to plot that root over at, -24 down here, and that's going to just provide me with some extra information to help me plot. So now I'm going to remember that this is a quartic. It's going to be looking more like a bowl, and it's going to be an upside down bowl. So I'm going to expect it somehow this graph is going to go through all of these. Remember, they are going to cross, since they're all single roots, they're going to cross each of these points without dipping and touching, but are also going to have to go through this. It's going to have to look like a upside down bowl in some way. So those are lots of pieces to put together, so let me kind of try to wing this. All right, so I would say, I'm going to have to go through here somehow. I'm going to have to go back and cross this guy. I'm going to guess I'm going to have to dip all the way down here, all the way up, and then cross back down. Let's see. So does that meet all of our criteria? Well, I used my x-intercept, or my y-intercept. It looks like a bowl, so that's consistent with my quartic function. It is opening downward, and it crossed but didn't touch through all those intercepts. So that looks pretty good in my book. I think that looks pretty good. Okay, so maybe now knowing that, maybe you needed to see that example before trying the second one. But what I'd like you to do now is I'd like you to try this second example here to see if you can sketch it, and then I'll take it up with you. Okay, so let's see how you made out with this. So when I look at this function, I can see that it is very similar to the last example in that it's also a quartic. I've got quartic, 4 factors of x, and it's also opening downwards. So it's going to look a lot like the last one that we saw. with the exception that I have a double root here, right? So I have an even order for my root at x equals 2. So let me just plot those roots. So at x equals 2, and then also I've got a single root at x equals 4, and I've got another one at, x equals -3. Let me see. So -2 squared gives me +4 times -4 gives me -16 times +3, so 30, 48. So how many negatives did I have? -48. But I also need to remember that there's this negative right out here. So it's actually going to be, my y-intercept's actually going to be at, +48. So I'm going to go ahead and plot that. So like somewhere way up here, this is obviously not to scale. Or there's a different scale on each axis. All right, so I know I'm just going to remind myself that there's going to be a double root at x equals 2, and I'm going to keep that in mind. So again, this is going to be quartic. It's going to be a bowl that opens downward, so it's going to start kind of in this zone and end over in this zone. But the difference is that it's not going to cross through at x equals 2. So let's kind of try to sketch that out. I don't know. So I'm thinking, this is what I'm thinking. I'm thinking it's going to go maybe up here, through here, maybe dip down, whoop, and then back up and then through. Yeah, I think that looks good. And so there we go. So up, dipping, touching, but not crossing at my double root, and then going right down through. That hits all the markers for me. I think that's a decent sketch. So hopefully you did okay with that. And if you struggled with it, then make sure to reach out for some help. So there's something else. There's one other piece to this that I want to talk about, which is it might describe the behavior of f at x at each interval. So if it talks about intervals where f of x is either increasing or decreasing, all they're talking about is different sections of the graph. So for instance, I might talk about, during the section where, and this is describing where x is less than -3, I might describe f at x as increasing, right? So what that will look like is a plus. Whereas if I were to describe, I'm going to pick a different color here, the next segment, so i.e. like right here, I might talk about that interval a little bit differently. So in other words, in the interval, in the interval where x is between -3 and +2, I might talk about how it is increasing and then decreasing, right? So in fact, I might also sort of separate that into two different intervals if I should choose, right? It also might talk about whether the graph is below or above the x-axis. So, in this section right here, I can see that in this section, f at x is increasing, but it's also below the x-axis, which means that f at x is negative during that interval. So it really depends on what question they're asking, whether they're asking what the behavior is or whether f at x is positive or negative for that section. So, right here I would say between the interval of +2 and +4, f at x is above the x-axis, so it would be positive. Here it's below the x-axis, so where x is greater than 4, f at x is going to be negative. It's going to be a negative section. Okay, so I hope that helps. It's not going to give you everything that you need, but it's going to provide you with some ideas so that you're not going in cold once you see them in, I guess, just a couple weeks from now. I'll also assign you some practice questions that you might want to take a look at. As always, reach out if you have any questions.